Hi, this is your Professor Sudha Kolathuparambil. In this section, you are going to learn how to find the absolute maximum and minimum values over a closed interval. This is a continuous function in a closed interval, let's say in the interval a to b. It has a maximum here, right? And the minimum value, lowest y value, that is here. So this is the absolute maximum, this is the absolute minimum. You can see that absolute minimum is at the end point, absolute maximum is at the critical value where the slope of this tangent line is 0 at this maximum. This is another graph which is also continuous in the closed interval a to b, and it has a maximum here and the minimum here. Both the maximum and minimum occurs at the critical point where the slope of the tangent line is 0. Absolute maximum or minimum occurs at the endpoints or at the critical values. The extreme value theorem states that if a function is continuous on a closed interval AB, then the function must have a maximum and minimum on the interval. The procedure for finding the absolute maximum and minimum values in a closed interval is first find the critical values and evaluate the function at the endpoints as well as at the critical points and compare all the values. Largest value will be the maximum and smallest value will be the minimum. The procedure for finding the absolute maximum and absolute minimum of f of x in a closed interval AB is first find the critical values. Assume while finding the critical value, we got two critical values C1 and C2. You can have more than one critical value or just one. Then evaluate the function f of x at the endpoints. So these are the endpoints as well as at the critical points. Then compare all these values and the smallest value will be the minimum and largest will be the maximum value. If you wish, you can make a table like that, then it will be easier. Then write A, B, those are the endpoints. Then write the critical points. Then find the corresponding y value by calculating f of A, f of B, f of C1, f of C2. Then compare all these values. In this example, we need to find the absolute maximum and minimum values in this closed interval. So this is A, this is B, this is the function. So first step is find the critical value. So take the derivative, factor out the GCF, then factor again, then set each factor equal 0 and solve. So we found two critical values for this function. We need to check whether these two values are in this interval or not. Negative 1/3, that is in this interval, but x equal 1, that is outside of this interval, right? Because this stops at 0. So 1 is not in that interval. So it has only one critical value, that is x equal negative 1/3. That is the only one critical value in this closed interval. Now evaluate this function at this critical point as well as at the endpoints. Then compare these values. So evaluating the function means we are substituting these values into the original function to find the corresponding y value. So substitute that into the original function. So replace this x with that value and calculate. Then substitute 0 and find f of 0, that is 10. Then compare all these y values. You can see that this is the largest value, this is the smallest. So largest value will be the absolute maximum. So we can write absolute maximum is 10.6 at x equal negative 1/3. And absolute minimum is 7 at x equal negative 1. There is one more theorem. Suppose f is a function such that f prime of x exists and there is exactly one critical value. Exactly one critical value such that f prime of c equals 0, then f of c is the absolute maximum if f double prime of c less than 0. F double prime of c less than 0 means the function is always concave downwards. Since it has only one critical value, that means the slope of the tangent line at that value is 0. So if this is c, slope of the tangent line is 0. That means f of c has to be the absolute maximum. Similarly, if f double prime of c greater than 0, that means the function is always concave up and it has only one critical value. That means the slope is 0 at this value. That means that is the critical value. So the graph will have a critical value here. So f of c, that is the y value of the function, that will be the absolute minimum. So we can use this technique to find the absolute extrema of a function um, which is continuous. If it is not a closed interval, we can still use this theorem to find the absolute maximum or minimum. In order to apply this theorem, it should have only one critical value and it should meet either of these two conditions. We need to find the absolute extrema of this function. So here the domain of this function is all real numbers. F of x is continuous in this interval negative infinity to infinity. First we will find the critical value. So find f prime of x, that is 4 minus 2x. Set this equal 0 and solve for x. So x equal to 2. So f of x has only one critical value, x equal to 2. We can apply the theorem we just learned. So we can find the second derivative. So second derivative of the function is negative 2. Now evaluate the second derivative at the critical points. So critical value is 2. So since there is no variable for the second derivative, it will be still negative 2 for any values of x. So this is a negative. So f double prime at the critical value is a negative number. If it is negative number, it will be always concave downwards. And f of 2 will be the maximum. So find f of 2. So substitute the value of 2 into the original function. So 8 minus 4, that is 4. So we can say f of x has, this is concave down, so it will be maximum, has the absolute maximum at x equal to, and the absolute maximum is 4 at x equal to 2, and there is no absolute minimum. There is no absolute minimum for f of x. Let me look at the procedure again by finding the absolute extrema using the second derivative. So first find the critical value by setting f prime of x equals 0 and solve. If there is only one critical value c, then find the second derivative and substitute c into that. If that value is negative, then f of c will be the absolute maximum. If that is positive, f of c will be the absolute minimum. So in order to conclude the answer, we need to find f of c. So substitute that critical value into the original function to find the corresponding y value to conclude the answer. What happened if we get a 0 while finding f double prime of c? This number can be a negative, positive, or 0, right? If you get a 0, we cannot conclude anything from that. We don't know whether it is maximum or minimum. We cannot apply this theorem. So we need to go back and apply the first derivative test. Find the absolute extrema of this function. So first step is find the critical values. So in order to find the critical value, take the derivative of this function. So apply the power rule. subtract 1 from the power, and derivative of 5 is 0. So 3 times x minus 2 square, that is f prime of x. Now set this function equal to 0 and solve. So x minus 2 whole square equals 0, that is x minus 2 equals 0, that is equal x equal to 2, right? So this is the only one critical value. So there is only one critical value for f of x, and there are no endpoints. So we can apply the second derivative test or maximum and minimum principle. That is, find the second derivative and substitute this critical value into that function. Or we can say evaluate the second derivative at the critical value. Or find f double prime of the critical value. So let me write that way. Find f double prime of the critical value. And after finding this, we are checking the sign. It can be positive, negative or 0. If it is 0, the test fails. Since the first derivative is this one, we can use that to find the second derivative. So I'm going to use the first derivative to find the second derivative. So apply the power rule again. Okay. I'm not solving this f double prime. I'm evaluating the function at 2. So 6 times 2 minus 2, that is 6 times 0, that is 0. If we get the second derivative at the critical value equals 0, that means the test fails. If the test fails, we need to go back and apply the first derivative test. Since the domain is all real numbers, this is a polynomial, right? So domain is all real numbers, negative infinity to infinity. So the number line will be negative infinity to infinity. And mark the critical point. So this is the critical number or critical value. Okay, and write down the factors of f prime of x. So we are checking the sign of f prime of x. So I'm going to take the test point in each interval. So here I can take a negative number, here I can take a positive value. My test points are negative 1 and 3. Since this factor has a square, even if the test points are negative or positive number, we will always get a positive number. That means this function is always increasing. So the graph of this function will be like that. It will be always increasing except at 2, because at 2 it has a horizontal tangent line. That means this function is always increasing. That means f prime is never negative. There is no maximum and no minimum for this function. Let's do one more example. Find the absolute maximum and absolute minimum of this function in this closed interval. So first find the derivative, set it equals 0 to find the critical values. E power 3x, so this is the shape of the graph. It's an increasing function and it won't cross the x-axis. So we cannot set this equation equals 0 and solve it. Basically there is no solution for that because it is not crossing the x-axis. There is no solution means no critical value. So f of x has no critical value. So absolute extrema must be at the endpoints of the interval. So evaluate the function at the endpoints now. So find f of negative 2 and f of half. So f of negative 2 is 2 times e power 3 times negative 2, that is 2 times e power negative 6, that is 2 over e power 6. Other one is 2 times e power 3 times half, that is 2 times e power 1.5. Since we are dividing 2 by e power 6, this will be a smaller number, and we are multiplying 2 by e power 1.5, that is close to 8.963. So this is the larger number, this is the smallest. So we can say that the absolute minimum is 2 e power negative 6 at x equal negative 2, and absolute maximum is 2 e power 1.5 at x equal half.